Hi, so what we have here is a logarithmic equation. Now, in order to solve logarithmic equations, we have to know a couple of things. We have to know the properties of logarithms, such as the quotient rule, product rule, and the power rule, as well as the zigzag method that we have covered in class. So, in order for us to proceed with this, we need to get all of our logarithms to one side of the equal sign. So, in other words, what we're going to do here, we're going to add the log of x on both sides. Okay. So when we add the logarithm of x on both sides, well, the stuff on the right side cancels out. The log of x is on the right side, cancel out. On the left side, we have the log of 2x minus 17 plus the log of x equals 2. Okay? So, let's see here. We added log of x on both sides. So, on the left side, we have the logarithm of 2x minus 17 plus the logarithm of x. So we have two logs separated by an addition sign. I emphasize the word addition is because we now have to use one of those properties that I mentioned before. So what property uses the addition sign of logarithms? The product rule. So instead of having two logarithms with an addition sign, we can now write it as a single logarithm. But now, 2x minus 17 times x still equal to 2. All right, so we can go ahead and multiply this out if you want to. Let me write my step real quick. So we can multiply this out to kind of clean it up a little bit. That's personal preference. So this would be log of, when we distribute the x into the parentheses, 2x squared minus 17x equals 2. All right? Basically, we just distributed the x. Now, to go from here, we need to convert it from a logarithmic equation into an exponential equation. But one thing to keep in mind, do you see a number down there at the bottom? No. So anytime we do not see a number at the bottom of a logarithm, that's an understood log base 10. So we need to emphasize that. So that would be log with a 10 down here. All right. So let me rewrite my little problem. So log base 10, 2x squared minus 17x equals 2. Okay. Now, to go from here, like I said, we need to convert it from a logarithmic equation into an exponential equation. Excuse me. And this is where we can use the zigzag method that we kind of talked about earlier. But how to see the zigzag method in action? Basically, we'll follow my arrows. 10 raised to the second power equals this stuff over here. That's why it's called the zigzag method. So this would be 10 to the second power equals 2x squared minus 17x. Okay, that's the zigzag method in action. So now let's clean this up. Wait a second before we do. We have a 2x squared. Anytime you see an x squared, automatically that's a quadratic equation. And what should all quadratic equations be equal to? 0, Mr. B. Yes, exactly, 0. So, to get there, well, 10 squared gets us 100. So we have 100 equals 2x squared minus 17x. So, in order to get it equal to 0, we subtract the 100 on both sides. So 0 equals 2x squared minus 17x minus 100. Alrighty. So here we can go ahead and we can do factoring. We can do the quadratic formula. We can complete the square. We can do a lot of stuff. Let's see here. Let's see if we can possibly factor. Can we factor this? Yes, we can. Okay, even for your instructor, it does take a little bit for him as well. Okay, so if we want to factor this, well, we have our two parentheses still. What times what gets you a 2? I'm sorry, what times what gets you a 2x squared? Well, that's a 2x and an x. Now, what times what gives us a minus 100? That when you FOIL it out, will also subtract to get you a negative 17. Well, I can tell you right now, that would be a plus 4 and a minus 25. When in doubt, always double check. You always want to FOIL it out just to make sure. So if I wanted to check to make sure that my foiling is correct, you always want to check. 2x times x. Let me check this. Well, that gets me a 2x squared. 2x times 4, positive 8x. Negative 25 times x, minus 25x. Minus 25 times a positive 4, minus 100. Aha! When you subtract and combine like terms, positive 8 minus 25 gets you a minus 17x. So that means I did factor it correctly. So since we factored it correctly, we can move on. We're going to take each factor and set it equal to 0 by using the zero product property. So that means that 2x minus 25 equals 0, and also x plus 4 is equal to 0. Okay, so when we solve each equation for x, well, here we're going to add 25 to both sides of that equation, so the 25's cancel out, and I'm left with a 2x is equal to positive 25. Divide both sides of that equation by 2. The 2's divide out, and I'm left with x is equal to 25 over 2. Okay, so now if we take the other equation, if we subtract 4 from both sides, 4's cancel out, and that gives us x is equal to a negative 4. Okay, so we have two answers. But wait a second, we have a problem. If you go back and double check your answer, if you plug it back into the original equation, you can plug in a 25 over 2 in for x. Okay, but here's the weird part. Let's say you plug in a negative 4 in for x. Problem is, you cannot take the logarithm of a negative number. So if we plug it in for x, well, we have the minus log of a negative 4. Automatically, that negative 4 gets thrown out. Because one of the basic properties, one of the basic rules of logarithms, you cannot take the logarithm of a negative number. It just does not work. It gives you an undefined value. So the x equals negative 4, we can throw that out the window. Now, all we have left with to check is a 25 over 2. In other words, if you go back to the original problem and you plug in a 25 over 2 in for x and work out the arithmetic, you should get a true statement. But I'm going to leave that to you guys. But I can tell you right now, x is definitely going to be equal to 25 over 2 because you will get a true statement. Okay, so that indeed will be our answer. So, some notes to kind of reference, all right? properties of logarithms, specifically product, quotient, and or power rule. Okay. And also, we come back to this all the time. Factoring and or foiling. Factoring and foiling, that comes up a lot. Okay? So it would not be a bad idea to even get more practice on your factoring techniques and your foiling techniques. Okay? So, as always, let me know if you have any questions of any kind. I'm happy to help. Until next time, best of luck.